Hi team. So someone was asking for the free response to section 6.2. So here we go. A container has the shape of an open right circular cone, which means the top's going to be a circle. As shown in the figure above, the height of the container is 10, so that's 10 centimeters. And the diameter at the top is 10 centimeters. And the water in the container, so this is the water down here. The water in the container is evaporating, so that the depth h, so that's the height of the water, so there's the top of the water and it goes down to here, is evaporating at a constant rate of -3/10 centimeters per hour. And notice that they're going to give us the volume for the formula for the volume of a cone here, 1/3 pi r squared h. So the first question says, find the volume V of the container when h equals 5. Indicate units of measure. So volume equals 1/3 pi r squared h. We know that h equals 5 at this point because they're telling us here. So, but we don't know what r is. So we know that the volume is 1/3 pi. R is unknown, but we do have this 5. So we need to figure out what that value of 5 is. The way we're going to do that is by knowing a little bit about similar triangles. So what we do is we create two triangles. So this is at the very top, and it's going to be half of that diameter. So that's going to be 5 centimeters. This is the entire depth of this, so that's going to be your 10 centimeters. But we've also created another triangle here. This one. Now this one changes. As the water goes down, then this radius is changing. So at any given time, we'll call that radius r. And this height is changing. At any given time, we'll call that h. Now notice that we have two triangles here. We got this big one. Okay, I'll show you where this triangle is. It's right here. So we have this big triangle here, and we have this little short triangle here. And they both have a 90-degree angle, and they're both sharing an angle, which means that they have 3 interior angles that are correspondingly equal. That means what we have here are similar triangles. So I have this large triangle is proportional to this smaller triangle, which means the side lengths are proportional. So if I take the larger one, 5/10, it will be equal to the same ratio as r/h. Now in this particular example, we know that h is 5 at this point. So it's going to be 5/10 equals r/5. Working that out, you're going to come up with r equals 2.5. That means that r equals 2.5 over here. Now, instead of putting in 2.5, I'm going to work without a calculator. I'm going to make that 5/2 times 5, and there's my squared. Because that's going to be, I'm going to be able to do this in my head. 2 squared is 4 times the 3 is going to be 12. So it's going to be, whatever I get is going to be over top of 12. 5 squared is 25, times 5 is 125 pi. Now the units are going to be centimeters squared times centimeters, so they'll be centimeters cubed. And that is my answer. So the volume is going to be 125 pi divided by 12 centimeters cubed. Okay, next question. Find the rate of change of the volume of water in the container with respect to time when h equals 5. Indicate a unit of measure. So again, we have V equals 1/3 pi r squared h. So we are given dV, no, we're not. Sorry. You are given dH by dt. And they're telling you, or was I wrong? Hold on. The depth is changing at a constant rate, so it's dH by dt, -3/10 centimeters per hour. and you are asked to find the rate of change of the volume. So you want dV by dt when h equals 5. So we're going to have a problem here. We have r and h's. So we need to relate r in terms of h. So once again, with your similar triangles, you know that 5 over 10 is equal to r over h. Now this time we can't put h equals 5 right away. We have to work with the overall proportion, which is going to be 1h equals 2 r's. And if we rearrange that, we're going to know that r equals h divided by 2. I'm going to use that proportion to change all of my r's into h's. So v equals 1/3 pi h over 2 squared times h. That's going to be volume equals 1/3 pi r cubed. And this is actually going to be 2 squared, which is 4, times 3 is 12. So I'll just change that to a 12. Okay, so now I want to take the derivative of both sides. So dV by dt, the 3 will come down. It'll reduce with the 12 to give me 1 over 4 pi h squared dH by dt. And we want that value when h equals 5. So dV by dt is going to equal 1 over 4 pi 5 squared dH by dt was given as negative 3 over 10. So this will work out to 5 squared is 25 times 3, negative is negative 75 pi over 40. Now on the AP exam you don't have to reduce, so we can leave that alone. I do believe that there's a common reduction in there, but I'm not going to bother finding it because you don't get any more marks for it on the AP exam. We are going to have to indicate units of measure, so it's going to be centimeters cubed per hour. There we go. Excellent. Next, show that the rate of change of the volume of water in the container due to evaporation is directly proportional to the exposed surface area of water. Well, the surface area, the exposed surface area of the water is a circle in this case, and its area is going to be given by pi r squared. So, when we say that something is proportional, we say that it is something like this: y equals kx, where k is a constant, and they are directly proportional. So in this case, we're trying to say that the rate of change of the volume of water is directly proportional to the area, the surface area, pi r squared. Now, in this case, this all relates to when h equals 5. Now, it should have said that in this question, but we can deduce that because it's part A, part B, and they haven't changed the exact height. So in this case, it's going to be when h equals 5. Now, we know that there is the similar triangles, and we know something about this. We know that when h equals 5, r equals 2.5. So what we're going to have over here is dV by dt is going to equal negative 75 pi over 40 equals k pi. Now 2.5 is 5 over 2 squared. So that's going to be negative 75 pi. I'll move this up a little bit. Negative 75 pi over 40 equals 25 pi over 4k. Remember, that's the constant of proportionality. So I'm going to bring the 4 up here, which is going to change that to a 10. I'm going to bring the 25 down here, which is going to change this to a 3. And the pi is going to come down and reduce with that. So we're going to find out that k equals negative 3 over 10. Now let's think about that for a minute. So there's a constant rate, a constant proportionality between the surface area and the volume, which is negative 3 over 10, which makes perfect sense because as the water in the container is evaporating, the depth is changing at a constant rate of negative 3 over 10. So regardless of the surface area, whenever the surface area is changing, we have a constant proportionality of negative 3 by 10. And there you go. And because it's a constant, there's no need to worry about units. Okay, all done.